Thanks for tuning in, everyone, to this Skywarn Weather Spotter introduction. This will be focused on Southern California. This is Alex Tardy, meteorologist with National Weather Service. We're going to talk in order here, providing a recap of the National Weather Service structure, tools, and services. We think it's important that you understand the National Weather Service and what we provide and how we provide it. We'll also talk about some extreme climate events of recent years. This is important for the whole weather-ready nation. We'll specifically talk about numerous weather types and hazards that affect Southern California. And hopefully you'll see that these hazards, including coastal hazards, are significant even for Southern California and give you some ideas of what you can report. Finally, and maybe most important for some of you, becoming a weather spotter and reporting the weather to us. We'll go in detail towards the end of the presentation. The presentation will be about an hour in length. We appreciate you taking your time and hope that you enjoy this information and eventually sign up to be a weather spotter and report the weather to us to help us with our mission of saving lives and property. Okay, National Weather Service, San Diego office. We're located in Rancho Bernardo. We serve all of Southern California, Riverside, San Bernardino, Orange, and San Diego counties. Now, typically, weather spotter training is not just online. We like to get out in the community, provide weather spotter training like shown in the examples here in these. Our weather spotters, we also work with a core group of county coordinators, and they also reach out to the individual counties. They don't provide the training, but they provide the information, the messaging, and they even allow us to host training in different parts of Southern California. Now, what do we do in Southern California when there's no weather to speak of? Well, we're going to show a lot of examples of weather, and hopefully you will see that there is significant, important weather here in Southern California. Now, National Weather Service is on social media, and you'll see a lot of times during significant weather events like shown here, we will post on social media, and you can post and share on social media and provide the appropriate hashtags. We're going to talk a lot about Santa Ana winds, regular wind storms from thunderstorms or from winter storms, floods, flash floods, snowstorms, and even coastal hazards. Across Southern California, thunderstorms are not the main thing we focus on, though we do have thunderstorms in Southern California. Now, I want you to be aware of our agency and what it consists of. National Weather Service is part of NOAA, National Oceanic Atmospheric Administration. National Weather Service has 122 offices as shown here. For this training, the focus is just on Southern California. But we work with numerous agencies across the state and also across the country as shown here, including a tsunami center, a fire center, a space weather center, water aviation, storm, climate, marine, and of course, weather modeling. One of the first and main things you should know is for Southern California, out of the San Diego office, this is the region that we cover with weather warnings, notification, and other alerts. This portion of Southern California you should familiarize yourself with because this is the area that this training is specifically targeting. You can see across the United States, this is how it stacks up. The number one weather-related fatality is caused by heat. Heat. The more traditional hurricanes and tornadoes, on average, each year are not the number one cause of fatalities in the United States. You can see rip currents make the list as well to the right. Now, in Southern California, the same thing. Excessive heat ends up being the top killer from all other weather hazards. Now, if you look at other events such as fire weather, windstorms, flooding, and even rip currents, they are also significant here in Southern California. Believe it or not, we've also had fatalities from lightning in Southern California. Now, at the National Weather Service, our responsibility is as listed on the left-hand side. The bottom line is to save lives and property and promote the economy. We provide a various level of forecasting information as shown here. Specifically, we send out impact decision support information to emergency management. But we also spend a lot of time in outreach and education, and we provide a lot of effort into providing urgent messages such as watches, warnings, and advisories. When there isn't any weather, we're also providing information on climate and climate statistics every day, no matter what the weather is. Now, as a weather spotter, we would want you to be familiar with basic services we provide. Call it the warning, watch, and advisories. We call it WAWA. Now, WAWA information is shown here. The most urgent is the warning, the watch comes next, and then you have the advisory. Now, in a most ideal situation, we'd want to provide a watch before a warning. And you can read the definitions here of why and what we would provide a watch for. Now, we often get questions about what advisories are, and they are listed here, and they're targeted more for the sensitive groups or the more prone areas for whatever the weather hazard might be, heat, wind, or flooding. Definitions of what a heat wave is are common here in Southern California, and also questions about climate, record. What is a record? How do you break a record? What's normal or a 30-year average? And those are also included here. Finally, we get a lot of questions about the zone. What do you mean the mountains, the coast, the deserts, that type of thing? So as a weather spotter, we want you to be familiar with those as well. Our National Weather Service operation is located in Rancho Bernardo. It's a 24/7 facility, always a meteorologist there, even during COVID-19. Our operation is shown here, and believe it or not, we do look out the window. On a busy day, our office is full of TV monitors and screens, as well as local media TV that we monitor to make sure that we are situationally aware of what is going on. But these are also situations when we need weather spotter help, in addition to social media. Now, other operations we do when we're not monitoring the weather in real time is we launch weather balloons in Southern California. It became automated in 2020. Did you know that? We also operate Doppler weather radar. Here's an example of the Santa Ana radar up in the mountains. Now, radar is only as good as understanding what the technology can detect. But believe it or not, the technology of weather radar can detect the difference between hail, snow, and rain. However, we do run into problems where the radar beam may be too high above the ground, or where the radar beam might be completely blocked. It can't go through mountains. And you got it, that's when we need weather spotters. Now, sometimes the weather radar will look like this, and it's actually not precipitating, or it is precipitating. And it's up to the meteorologist or the radar operator to be able to discern the difference. You may not know the difference between ground clutter, about anomalous propagation, or even understanding inversions or identifying false echoes on the radar. That's what the meteorologist is for, but you can help with the meteorologist to verify what is landing on the ground. Sometimes across our region, the echoes might show up like this, and they may look real because the radar does not know exactly what it is looking at, and it's up to the meteorologist to determine if it's false or not. Sometimes we have echoes that we call chaff on the weather radar. We use other sources like MPing to report that weather. Weather spotters can help in that scenario as well. Sometimes it's a mixture of rain and false echoes that aren't actual precipitation. Now, we use other tools such as weather satellite to help determine. Sometimes echoes coming in off the coast may look exactly like precipitation or even a frontal system or even a thunderstorm, and they are not. But this is situations where the meteorologist needs to use multiple tools, including satellite, weather spotter reports, and the technology of the radar to determine what is actually coming in or on the radar. Now, another way we can determine about if the rain is actually occurring or if it's snowing or how windy it is or what the temperature is to use automated weather stations. Believe it or not, we do not own or operate most of these weather stations, just the ones at airports. But we tap into a large, massive network of private and public. Public may be you providing a weather station at your home. Private may be a utility company. All that information is shared and posted on this map here live off of our webpage, and you can use that information just like we use it to determine how severe the weather is. Okay, admit, you might have thought at one point, how do we observe or predict the weather, and how come we're so far off on both of those? Well, we could resort back to the weather guides. Those are helpful. When the rope is wet, it's rainy. Can't see the rope, it must be very foggy. If the rope is frozen, it probably snowed. Well, in all honesty, we need weather spotters to help us out for reporting the weather, and we need the best technology to help us observe the weather and predict it so we can meet our mission of saving lives and property. We're not asking you as a weather spotter, if you do join up, to chase storms like shown here. We are not asking that. There's a difference between storm chasers and weather spotters. Now, across California, we've seen a lot of extreme weather over the past several years. Some of those events are listed here. Take a look at these events and see if they impacted your region. But we also need weather spotters, in addition to social media, to report that weather to us so we don't miss it. So we document it and we report it and keep it in the long-term, what we call climate database or storm database for our region. Some of these events have been very significant across our region. Some of them are hot weather. Some of them are even cold weather listed. Some of them are damaging winds, such as 2016 and 17. And we'll show a lot of examples of those. Or flooding that we had in 2018 and 19, which we'll show examples of as well. The weather is not dependent just on La Nina and El Nino. Right off the bat, you need to understand that we can have severe weather and flooding weather, and we can have droughts even in El Nino or in a La Nina. It is not just dependent on El Nino or La Nina here in Southern California. Remember the super bloom of 2019 after that wet winter and the poppies exploded around Lake Elsinore? Here are some photos I wanted to share with you of that historical event after a very wet year. And the rain occurred at the right time during the heart of the winter. Let's talk now about some significant weather impacts across Southern California. Santa Ana winds. The easiest thing to remember is it's wind blowing from high pressure at the surface or cold air towards our coast. We wouldn't have much impact, though, if it wasn't for our mountains. Our mountains are the difference maker because the air is forced to go between and or up and over those mountains as shown here. Santa Ana wind, in a nutshell, is high to low pressure. It's a dome of cold air over the Great Basin. When we look at an average of 10 years, we can simply see that surface high pressure that settles over northern Utah is the common culprit to bring us high winds. We wouldn't get those high winds, though, like we normally see in a Santa Ana wind that can be as much as 100 miles per hour or as little as 10 miles per hour. The mountains and the gaps between those mountains really enhance those winds and cause the problem here, unique to our region in Southern California. Santa Ana winds, no doubt, signal a message to us that it's going to be very dry, it's going to be windy, and the fire danger is likely to be high. In October 2019, we had that same scenario. This particular fire broke out early in the morning on Halloween Day. Several homes were destroyed. Luckily, firefighters were able to get everyone out of harm's way, but it was a night to remember in Southern California for this community. The winds can be devastating in terms of their impact, as shown here, toppling over trees and cars and other objects. They can start fires, and that's our number one hazard here in Southern California is wind-driven hazard of a wind-driven Santa Ana wildfire. Now, wildfires can be explosive and devastating, even in scenarios where there's no Santa Ana wind. Take a look at this wildfire that started in July 2020, called the Apple Fire. These fires can be large. These fires can be out of control. These fires can spawn other fires across our area. Now, after the fire, this is typically what it looks like. The terrain is scorched and burned. Wildfires can present new problems once those areas are burned and there's no more vegetation to absorb the rainfall. And Santa Ana type winds can occur with or even after cold winter storms. As shown here, 3 separate events in January and February 2020 left numerous large trees down and toppled over dozens of semi-trucks, especially across the inland empire of Southern California. Let's talk a little bit about winter storms across our area. Winter storms can be a high impact across Southern California, from flooding to snowstorms to wind. Here's an example of the Thanksgiving storms of 2019. There were 2 different types of impacts from these storms. The obvious heavy rain, as shown on the radar image here, produced torrential flooding and flash flooding in parts of San Diego. But also, we saw microbursts damaging winds along these cores of very heavy rain or thunderstorms, including in an area near Poway. Winter storms can cause so much rainfall that we are inundated and flooded across our region, as shown here in April 2020. Now, we typically call these atmospheric rivers, right? Well, all of them are not atmospheric rivers that cause flooding, but atmospheric river is the terminology that we focus on, especially when we start talking about water supply and also water impact or flooding. Here's a storm in Southern California that was not an atmospheric river, produced tremendous amount of rainfall in 1-day period in Orange County and San Diego County. In fact, some places received over 2 inches of rain in 2 hours. It caused flooding, but it also caused debris flows. Debris flows are something that can occur on a wildfire scar, where the terrain is bare and burned with no vegetation to absorb that water. It can also cause flooding downstream of that burn scar, such as what happened in Lake Elsinore during that December 2018 event. Now, other types of events that are atmospheric rivers can do the same thing. 2 inches of rain in 2 hours at Seal Beach from this particular storm, widespread flooding in that region. So we had one storm that was an atmospheric river, one that was not. Both of them produced 2 inches of rain in 2 hours. What's an atmospheric river? An atmospheric river is basically a source of moisture off the Pacific, typically tapped into the tropics, as shown here in the red shaded area. Now, when we tap into that moisture and bring it across our Southern California mountains and coastal slopes is when we can see some real problems, like we saw in February 2019. We can also see problems in our mountain communities, such as Big Bear, Mount Baldy, as shown here, and we can see wind damage in these storms, as shown to the right. So they can pack a big punch in terms of wind, in terms of rainfall. Now, one of our most devastating atmospheric events was 2019, as shown here. In February, Valentine's Day, this particular storm not only brought heavy rain to the mountains, but also to the deserts. Flooding was widespread. Millions of dollars of damage. Roads up in the Riverside County mountains were closed for 6 to 9 months following this particular atmospheric river. We set records with this particular storm, and records that weren't necessarily good. 24-hour rainfall record at Idlewild was broken. Immediately, this storm required $35 million to repair the roads and another $30 million to make the roads safe and make them capable of handling a similar storm in the future. National Weather Service has a program called Turn Around, Don't Drown. Flooding is not just a problem in our mountains in Southern California, also can be a problem in our valleys, as shown here in Mission Valley, in flooding back in December 2010. Winter storms can be intense across Southern California. In particular, we had a storm in February 2017. This storm packed a punch with heavy rain, atmospheric river, and also very high damaging winds, just like you might see in a weak hurricane. This particular storm wiped out Interstate 15, as shown here, on February 17th, 2017. Too much rain, all of a sudden, 4 inches of rain in 12 hours through the Cajon Pass caused widespread damaging flooding. Now, winter storms can also produce small-scale storms. And what do I mean by that? Winter storms can produce individual lines of thunderstorms. And these thunderstorms themselves can cause significant wind damage to our community, as shown here in Poway in San Diego County. Winds can look like this, toppling large trees over homes, over automobiles, and truly causing damage and even fatalities. Take a look at the wind damage from this one particular storm in Vista, as shown here. And a similar thunderstorm and a big winter storm in January 2016 produced what appeared to be a tornado. We visited this location and did a storm survey and determined it was microburst straight line winds, but nonetheless, winds around 65 miles per hour snapped and toppled over trees at this location in Poway, very close to the National Weather Service office. Now, we also have to deal with heavy snow in our winter storms. And heavy snow is really a problem for our mountain communities, especially above 3,000 feet. Heavy snow can damage power lines. It can cripple travel, making roads dangerous, hazardous to any type of travel, and can be difficult to keep up with even snowplows. Well, it's Southern California, Christmas Day 2019. Not only does it not rain in Southern California, how could it snow? Well, this event on Christmas Day produced heavy snow across Southern California and the interstate passes. This is Cajon Pass here, where it became a standstill. No longer could they keep up with the movement of traffic along this major interstate. Cars became stranded, roads were snow covered. Eventually the road had to close until they could get all the vehicles off and then remove all the fresh snow. Snowfall fell at a rate of 1 to 2 inches per hour. So blinding visibility and treacherous conditions right after Christmas in 2019 through the Cajon Pass. Now, what are some of the definitions that we use with winter storms? Well, with winter storms similar to high wind, we're expecting heavy precipitation and or high wind, and we issue a winter storm warning, the highest level of messaging. Before that, we plan to issue a high wind or winter storm watch. This could include a Santa Ana wind event, but it also could include heavy precipitation episodes here in Southern California. Now, one thing we ask from weather spotters, and this is the most difficult thing for weather spotters to produce for us in real time, is snowfall reports. We ask you to report the snowfall. We are always looking for new and total snowfall reports, and it can be difficult in measuring snow. It's not as simple as just looking at your porch and saying, oh, there's 3 inches, oh, there's a foot of snow. We need accurate and timely snow reports from our weather spotters, and we provide that training to our weather spotters to show them how to do it. All right, so snow in the mountains and the mountain passes are one thing. They're used to it, right? Well, how about snow in the lower elevations? This event in 2014, do you remember it? Along Interstate 15 that was shut down. Not only did it receive heavy snow along the 15 and in elevations around 2,000 feet up to 2 feet, it crippled the area with hundreds of trees damaged as shown here. This photo here is not photoshopped. This isn't Lake Tahoe. This is the mountains surrounding Lake Elsinore, following this historic snowstorm that shut down Interstate 15 in Wildomar. This was taken the day after with the fresh snow cover across the slopes, looking more like a ski resort. Now we also see damaging winds, not just from Santa Ana winds, but in the core of a winter storm, okay? And these are critical winds that can impact the deserts, and they can also impact the coast. And these are not Santa Ana winds, but they occur in winter storms. What are the definitions of wind alerts that we produce? Here they are listed, with high wind warning being the most significant message we can send out about damaging winds, particularly damaging winds in a winter storm or in a Santa Ana wind event. Now, the storms in Southern California during the winter don't just come with precipitation, they also can come with fierce winds, as shown here at Wrightwood. Wind gusts of 70 miles per hour in some of the stronger storms impact our highest terrain, can topple over even big, strong, healthy trees. One of the most high-impact storms was a combination of cold, downsloping air and a little bit of Santa Ana. This system moved through November and early December 2011. It toppled near 400 trees in Rancho Cucamonga, but at the same time delivered up to 18 inches of snow to Big Bear City. They can also produce damaging winds in areas that are used to high winds in the deserts, power lines, vehicles, high-profile vehicles in particular, like shown here. Now, sometimes those winds can affect the coast, such as this storm in January 2016. We had 24 hours of winds gusting 40 to 60 miles per hour along coastal Orange and San Diego County, as shown here. Lots of damage from this particular storm during the January 2016. Unfortunately, we also had fatalities from massive trees that landed on vehicles and literally crushed the vehicles during those winter storms. Here is a winter storm that packed the punch. Mid-January 2017, high winds affected most of San Diego County. Hit particularly hard was Chula Vista with over 600 trees downed. Wind gusts were clocked at 65 miles per hour. Some of the wind spread all the way up into Orange County coastal areas. Here's a photograph from a survey that we took with a large tree that fell across a home in Encinitas. Luckily, no one was hurt. The winter storms can also be non-winter looking. They can produce dust storms in our desert areas if there's no rain, like shown here in these particular storms. They can reduce the visibility and cause hazardous travel across those areas. All right, let's shift gears here and talk a little bit about thunderstorms. When people think of weather spotting and weather reporting, they typically think of thunderstorms because of tornadoes in the Midwest or high winds and hail in the Midwest. But here in Southern California, we do have thunderstorms as well at a different level. Thunderstorms in Southern California could look like this, an actual supercell thunderstorm. Photographed here, it was occurring in the deserts in August of 2017. Now, thunderstorms can also look like this. They can have a powerful looking wall cloud. They can have a powerful rain shaft on the right-hand side, and they can have a clear area on the left-hand side, and they could be rotating. In this training, we're not going to get into what causes a rotating or severe thunderstorm, but it is something in our more advanced classes we talk about. A thunderstorm in its basic sense looks like this. You have a cumulus cloud growing, it gets larger and larger, becomes mature stage, and then it dissipates, and then it produces, at that time, heavy rain, and even sometimes high winds, as well as lightning and maybe small hail. Thunderstorms on radar, compared to what they look like in the sky, could be shown exactly like here. This example here is a picture of a thunderstorm in the distance and also what it looked like on weather radar. You'll notice as a weather spotter or just someone that's following weather closely that clouds take on many different formations. One of the clues to lightning is the glaciation, or the ice layers that form on the top of a cumulus cloud. Remember, the clouds can be as high as 30 to 40,000 feet, penetrating way up in the atmosphere, as shown here. On satellite, this is what the same thunderstorm could look like, as shown here. Notice it's clear across all the coast and valleys, and those people are thinking like, what thunderstorm are you talking about? Meanwhile, a massive thunderstorm is building over the mountains, as shown here. Now, in our advanced class, we get into a little more about where thunderstorms are more common, such as the Elsinore Convergence Zone or some of the Desert Convergence Zone. In this training, for purposes of keeping it brief, we are not going to go into this detail. Take a look at what it looks like to see a thunderstorm form. Take a moment to observe how each frame can be dramatically different with how the storm is growing or dissipating and then blowing off its moisture towards the north in this particular case because of the prevailing wind coming from south to north. Here's an example of what a thunderstorm can do in Southern California when you have a recent burn scar. This produced 10 feet of debris across Highway 38 up in San Bernardino County back in 2018. Here's an example of the Holy Fire, which produced numerous debris flows and mudslides in 2018-2019. This was one of the first debris flows that occurred in December 2018 after heavy rain moved over the large burn scar in Riverside County. Please take a moment to watch this additional video on YouTube and see exactly what we mean by fire scars and debris flow. Here's an example of debris flow from a thunderstorm over Mount San Jacinto back in 2013, and it traveled all the way down to Palm Springs where it was not even raining. Thunderstorms across Southern California can produce what we call cloud microburst winds. That's basically a large water balloon collapsing from the thunderstorm and producing intense winds along with the heavy rain. It can be very dangerous to aircraft, also dangerous to trees, power lines, and anyone underneath it. Here's an example of our region in Southern California of a classic microburst in August 2017 and the damage it produced. Here is a classic example of what we mean by a severe thunderstorm. This occurred in July 2018. These photos were taken after the event during a storm damage assessment that the National Weather Service conducts. You can see large trees were snapped and uprooted in this park after thunderstorms erupted on a very hot day in July 2018. Here's a photo of a severe thunderstorm that contained heavy rain, produced flash flooding, and strong winds. This was located in the city of Hemet, photo taken in summer of 2020. A collapsing thunderstorm is a dangerous situation. We see this almost every year in parts of the Coachella Valley. Here's an example in 2019 where a thunderstorm built up over the higher terrain, moved off the terrain into a hot area, but lost the support to keep the thunderstorm going and collapsed. Winds gusts of around 65 miles per hour in the lower Coachella Valley produce devastating damage to utility lines. It can also produce large trees toppled over vehicles, as shown here in 2014. Thunderstorms, when they do form in our region, can produce damaging winds like shown here. And also dangerous, deadly lightning that can spark fires such as shown here. Here's what can happen in a city such as Riverside. This actually happened 2 summers in a row. Microbursts, wet microbursts, flooding, damage to the city with large trees toppling. Take a look at the photo shared from a weather spotter on the left-hand side. This can be a very dangerous situation when it moves over a metropolitan area as shown here. And another image of what those trees can do as shown here in Riverside. More information, you can watch the video from the Press Enterprise on YouTube. Now, thunderstorms on satellite, out the window, on radar, all look different. But here's an example of looking at a thunderstorm at different viewing angles across our region. Now, from an airplane, how about that perspective? A thunderstorm can look like this with this massive downburst of heavy rain across our region. This particular photo was taken in Alpine, California. And here's what it looked like on weather radar. Another comparison of what a thunderstorm might look like in the distance and what it might look like on weather radar to the right. If you've ever followed the weather or lived in Florida, you know what this is, but this is Southern California. An offshore flow from a tropical system to the south, and then the normal onshore sea breeze collided, producing a line of thunderstorms that all formed during the early afternoon as shown here. Thunderstorms actually ended up producing damage in the San Diego area as they became intense, severe thunderstorms in the afternoon along this boundary. Now, part of being a weather spotter is knowing the difference between a flood and a flash flood. We'll give you some examples in this brief training. Heavy rain is common across Southern California in the summer months and also during the winter. Sometimes too much rain in a poor drainage area or the wrong place can lead to a lot of standing water. If you drive through it, it still could be dangerous, but it may not be a flash flood. Other cases, too much rain in the wrong location at the wrong time all at once can lead to what we call flash floods. That's water entering property. That's water that causes vehicles to stall. And that is water that could be dangerous and cause drownings or a vehicle to literally be pushed off to the side. Here are some examples of a mixture of flooding in low-lying areas and flash flooding causing damage in other areas. Sometimes the situation is very clear whether it's a flash flood or not. Here's an example of a road closed, impassable by swift moving 6 inches or more of running water from a monsoon thunderstorm on Highway 78. Another example of a classic, deadly, dangerous flash flood across a highway here in Southern California. In other cases, it can bring rocks, mud, debris. And this could be regardless of having a wildfire or burn scar nearby, as shown in this example in 2014. The water can be as high as a person or even higher as it swiftly moves through and rushes through our complex terrain. Now, when we see this type of rainfall in our desert areas, it turns into a muddy mess like shown here out by Palm Springs in 2014. One of the most high-impact flash flood events in recent memory was Mecca, California, September 11th, 2011. There was 6 inches of rain in just a couple hours during a summer thunderstorm at this location, just inundating the area with flash flooding. We also saw back in 2014 in San Diego Estates and Ramona, where rainfall of nearly 4 inches occurred in 2 hours. A similar event occurred out in La Quinta, in the lower portion of the Coachella Valley. Rainfall here was measured around 4 inches in 2 hours from a September monsoon thunderstorm. Here's a few of the NBC photos taken from that day of historic rainfall. Earlier, I briefly mentioned about the Turnaround Don't Drown program. Here is an example caught on a video of a vehicle doing just that. The vehicle, in white at the top photo, approached the water and debris, determined that they could not tell if it was safe to cross, and they literally turned around. It could have been catastrophic if they tried to drive through with the water, with the debris, and the unknown of if the road was even there underneath. Thunderstorms can cause flooding in our deserts, can cause flooding and flash flooding, and even massive walls of water, as shown here, that move through Anza, Borrego, Fish Creek. Here's an example of a flash flood in 2017 captured in a dry wash. It may not even be raining at this location, and water is rushing down the mountain slopes as shown here. Dangerous situation for anyone. Tornadoes, yes, they do occur even in Southern California. This map plots the location of where tornadoes have been observed and where we have estimated the damage. Each tornado event will require to go out and examine the exact damage and determine whether it's straight line or actually tornadic damage so that it can be recorded in our storm data for historical information. You can see along the coast and even the inland valleys, with the favorite area being the Inland Empire, but also there have been many events where water spouts and or land spouts have occurred, both are tornadoes, from the water and over the land, such as in Orange County. One of the most spectacular tornado events in Southern California was this storm in Mecca, California. The most costliest storm from a tornado in California history, where $18 million of damage occurred mainly to steel power lines as shown here. The storm was impressive on radar. Storm was an intense thunderstorm that actually moved left as it drifted northward towards Mecca, just north of the Salton Sea. The overshooting top could be seen far away. Here's a tribute to the late Steve Bier from Anza Borrego State Park, as he had bird's eye view of this mammoth of a thunderstorm in the desert. This is a vivid photograph of a tornado in the high desert. You can see the column of spinning air, rotating dust is being drawn, and it's connected all the way up to the parent cloud or the actual thunderstorm and cumulus. This is what we would call a landspout tornado. Now, sometimes the situation is difficult to tell whether it's connected to a parent thunderstorm or not. In this case, it may only be a dust devil. Other situations are even more difficult, where you have a large thunderstorm in the distance, as taken here. It actually took me some time to determine, was that actually connected? But it turned out it was a large dust devil on a hot day with a thunderstorm in the background. They were not connected. So it was not a tornado or a landspout. In other situations, it is connected, and we're able to determine if it's a landspout or an actual tornado. For all these situations, weather spotters could report this information to the National Weather Service, and we would actually go out and do a survey, like in this particular case here, and determine, was there straight line or tornadic damage or neither? Hail. This is something that you talk about a lot in the Midwest, where it can be as large as a softball. Believe it or not, we can still get hail here in Southern California. The best way to determine the size of the hail is to use a coin or a ruler. Hail can typically look like this on our ground. You can tell the difference between hail and grapple by grabbing the actual stones. If they're hard and ice, even though they're melting, they're hail. If they pop and they're soft, it's probably graupel. And graupel is more common in our mountain areas versus our lowlands. Here's a simple way that our weather spotter Jerry took a ruler and measured the hailstone. You can also use a coin if you have one available. Now, it's often confusing about what you might be observing. Is it ice pellet? Is it graupel, like the upper left? Is it an actual hailstone, like the upper right? Or is it neither? Is it a snow grain, which is frozen drizzle, tiny little pieces of ice? This type of reference information is what we provide our weather spotters to help them out in determining what type of precipitation it may be. Like I said before, the snow pellet and the graupel is more common in a winter storm in our mountains. The small hail is more common along our coastal and valley areas in a winter storm or in a monsoon thunderstorm. They are completely different in the way they appear and the way they feel if you were to pick up the stones and the way they are formed in our atmosphere. Here's some more examples of hailstones across our area. This is one of my favorite photos. We won't go into the details of how this particular thunderstorm formed, but it was an elevated thunderstorm on August 20th, 2014. This storm moved across the valley area near Nuevo. The photo produced large hail and accumulating hail. You can see the cold hail and the rain caused a layer of ground fog to form immediately afterwards as well, after a hot summer day. A great photo of widespread hail from a thunderstorm. We can also see hail in our mountains, and it may not be graupel. It may be actual real hail, like in this case here in 2017 in July. It's hard to believe sometimes, even when temperatures are hot in the middle of the summer, hail can form and land on the ground, making it look like it snowed. Speaking of snow, was this snow or hail in Huntington Beach in 2015? Actually, it was an early spring storm that produced widespread hail that accumulated. Hail accumulated in Huntington Beach. Not snow and not graupel, but hail. All right, let's talk a little bit about lightning. Lightning is important. Lightning is somewhat rare in Southern California, but it can be deadly even in our part of the world. Here's a photo of lightning that struck a tree in Southern California and caught it on fire. Lightning can be 5 times hotter than the surface of the sun. It can be as hot as 50,000 degrees. A lightning event in 2018 produced hundreds of strikes here, even in Southern California and even on the coast. Here's an example of a flag football game that was going on in Carlsbad, California. The game was not called off until lightning started to strike right nearby, as shown in the photo in the lower left. Lightning struck right nearby on the field and everyone was scrambling. Initially, they started scrambling because of the rain, and then the lightning occurred. This was definitely something that was avoidable, preventable, and actually predictable for the safety of everyone in that area. It's important to understand that lightning can even occur in coastal California on our beach and in our nice coastal cities. In this particular case, the thunderstorm was approaching miles away from the southwest with lightning in the far distance, and everyone could have been notified about this in advance. Here's an example of lightning again on our coast in early morning hours in 2016. Hundreds of strikes occurred in this particular event in fall 2016. Lightning, like I said, is not common in Southern California, but it does occur on our coast and especially over our mountains, typically in our mountains and deserts during the summer monsoon period. A significant event in 2015 during the summer really was an eye-opener to our beaches and to those who like to spend summer afternoons in beautiful Southern California. Thousands of lightning strikes occurred, and even lightning strikes along our beaches. Here's an example of when some of that precipitation started moving up from the south along our coast. Here's what it looked like as it moved through. Thousands of lightning strikes hitting almost every single location across our beaches, across our coast, across our valleys, and even over our mountains. All right, let's talk about heat. And earlier in the presentation, I said heat is the #1 danger in Southern California. Then I certainly should talk about it. Excessive heat warning is our highest level of urgency for heat alerts, but we also issue other products as shown here. The excessive heat warning means it's unusual. It's going to affect all people, especially if those people don't take precautions. It's not going to affect just the heat-sensitive groups, like the elderly or the kids or those that are sick. Heat events can be a killer, and believe it or not, temperatures can soar up to 110 even along our coast. In this particular event here, shown September 2020, all-time high temperatures were reached across Southern California. Now, heat risk is something that we have developed here for California, and it basically highlights areas that are not only unusually warm, but unusually warm for their location for any time of the year, and could be a high impact to someone's health if precautions are not taken. All right, also here in Southern California, we have what are called tsunamis. And believe it or not, in 2011 and in 2010, a tsunami reached the California coast. Now, typically we don't see it as a wall of water. It's typically strong currents and a series of waves that affect our coast. What are some of the definitions of tsunami alerts? Well, the most important one is the tsunami warning. That's a message that would go to your phone, go to your TV, and that's a serious situation for expected series of tsunami waves that will cause inundation, or in other words, flooding on our coast. But we have other levels, the Tsunami Watch, which becomes before the warning, and the Tsunami Advisory, which may only be strong currents or a series of small waves on our coast. These are important to understand. Here's what a tsunami might look like in Southern California. Not that giant wave that you're expecting, right? But a series of strong currents that are so strong that you can't even swim in them or even control your boat if you try to move through them. It can be a surprising and potentially deadly impact in our bays and in our harbors of Southern California. Historically, this is a list of some of the tsunamis that have occurred in Orange County. Take a look if you recall any of these, like 1964 or 2010. Tsunamis are typically a series of waves, basically a series of tides that occur every hour, up and down. And that motion of all that water can result in very strong currents, not rip currents, but strong currents in our harbors and bays. Enough to break a dock, enough to push a ship or push a boat off of its moorings. Tsunami.gov is where you would turn to the latest information, and we would use that information and provide more additional local information here in Southern California. Rip currents. I mentioned earlier in the presentation that heat is the #1 weather fatality from natural hazards in Southern California. Well, rip currents are right up there as well. Rip currents are another silent and sometimes invisible hazard along our coast. We work closely with the lifeguards here in Southern California, such as the signage that you see here that we've posted on our local beaches for rip current hazard. The marine layer is something you'll hear talked about a lot if you're new to Southern California, or even if you've been here for a long time. The marine layer is typically our free air conditioner, but it does have impacts with it in terms of fog, low clouds, and other hazards that might affect shipping, and boats along our coast, and also our traffic along our major highways. So not the most exciting weather, but we do encourage weather spotters to report dense fog. Dense fog can be the result of that marine layer along our coast as it intersects the terrain in Southern California, but it also can form in our valleys, in our mountain valleys, as shown here across the Inland Empire in January 2018. Dense fog can be hazardous and even deadly, causing accidents and severe restrictions to visibilities. And that morning, this is what the dense fog looked like at the parking lot at our office. Now, the other hazard we have along our coast are giant waves. Waves can be as large as what you see here along our coast. If you're able to surf in those waves, it may be fun. Along the coast, it can cause a lot of damage and erosion to our beaches and some of our property. Some of that erosion can look like this, and some of that erosion can lead to rock slides and even landslides across our coast, in addition to major beach erosion during and after winter storms. Here's one thing you didn't expect us to talk about is hurricanes. Can tropical cyclones affect Southern California? Well, they show here that they have historically. Here are some recent events in the past several years that have brought widespread either thunderstorms and or heavy rain to our coastal areas and our mountains and deserts, such as 2016 and 2015. We've also seen indirect impacts such as massive flash floods in our inland valleys and mountains, such as 2014 and 2015, or most recently from Rosa and Sergio in September and October 2018. Hurricanes can even cause coastal impacts such as strong currents and coastal erosion, such as 2014 with Marie. All right, now that you're seeing the different weather types in Southern California that impact us, and you see that some of them are real and some of them are significant in how you can potentially help us, here is how you can report the weather to us. It's easy. We provide our weather spotters a 800 number. We provide them with online internet access to reporting. We collect information through ham radio, through social media, through regular email, or through their county coordinator. Weather.gov is the place you go to report the weather, but also to sign up to become a weather spotter. This is what our webpage looks like when you click on San Diego or Riverside. This page pops up, and you should be familiar with this page if you are a weather spotter. We provide basic observing information on here, climate information, forecast information, pictures of weather, and we also have our point and click page, as well as our watch warning advisory that you are now an expert of. That information posts automatically on weather.gov. Now, to sign up to be a weather spotter, you go to the local programs tab, click on Spotter and Skywarn as shown here. Up pops this page here, and you now can click on the online training and the online method for providing your information and officially signing up to be a weather spotter. We need your contact information, and we need to know that you've gone through all the training. Here's the type of information we want you to report. We talked a lot about snow, flooding, the difference between flash flooding, believe it or not, tornadoes, and that funnel clouds are not tornadoes. We taught you how to measure hail, how to report strong winds, and the different type of winds, Santa Ana winds, or maybe even a winter storm wind, or perhaps a thunderstorm microburst. We want you to report rainfall that may require you measuring the rain, or it may require you to take a photo of the flooding that resulted from that heavy rain. We talked a little bit about lightning, extreme temperatures, and how those are impactful to human health here even in Southern California. We talked about some other silent hazards such as rip currents and the surf. We talked briefly about dust storms, and on that note, dust storms and dense fog can also be reported in the same fashion. We talked about how this could be an impact to transportation or to our general society, whether it be dust, heat, classic thunderstorms, or wintertime high winds and flooding. All of those are reportable to the National Weather Service as a weather spotter. How would you report it on our webpage? Well, the same webpage that we showed you before where you sign up, under current hazards, you click Submit Report. Up pops a nice little image like this on your smartphone or your desktop. You pick the weather element, rainfall or snowfall. Next, you add your location. Finally, you add some of the details to what you're reporting. This person is reporting dense fog with visibility of 1 mile. Then you provide your contact information or your weather spotter ID, since you're going to be signed up, and you send the report. The report immediately goes to a National Weather Service forecaster in operations 24/7. There's also a way to download an app and report the weather. If you choose to do it that way, you don't even need to be an official weather spotter. It's called MPing, and I briefly talked about it before and how MPing teaches our weather radar to be a little bit smarter and teaches our weather forecasters and our meteorologists how to better identify whether the rain is reaching the ground or how large the hail may be. We appreciate your time. We hope you decide to sign up. We provide a longer training session online on our same YouTube channel where you can get additional information and much more detail about the meteorology of many of the weather hazards that we talked about. We need weather spotters to report the information to us so we can better protect lives and property and improve our weather forecasting abilities in the future. Thank you so much for taking the time to watch this presentation. We hope you found it useful, and we hope you do sign up and participate as an active weather spotter in the Skywarn National Weather Service program. Please be safe out there when reporting weather to us. Thanks for tuning in.